Yes, so guys, we'll start with division. Okay, and then if we have time, we will discuss some problems related to addition, subtraction, multiplication, and division. So Swastik is there, Parth and Yashika. Are you guys there? Okay, okay, Yashika, fine. So let's start now. Uh, so first of all, what is division? Okay, so division is splitting into equal parts, okay, or put into groups. So let's say if you have 12 and we divide it by 3. So what are we doing essentially? We are actually splitting 12 into 3 equal parts. So let's say this represents 12. So we are splitting it into 3 equal parts. Okay, or you can place it into 3 groups. This is 4, this is 4, this is 4. So division is splitting into equal parts. You can also say that it's repeated subtraction. Okay, Parth. Yeah. So I hope you guys are familiar with the symbols. So we use this symbol, or you can also use the slash. Okay. You can also write it like this. Now let's look at the division facts quickly. So all of you are familiar with this, but for the sake of the lesson, let's just quickly go through them. So the first one is when you divide a number by itself, the result is 1. Okay, so 4 divided by 4 is 1. Take any number, divide it by itself, the answer would be 1. Okay, and the second fact is when you divide a number by 1, the answer is the number itself. Okay, fine. Third fact is if you divide 0 by any number, the answer will always be 0. Okay, and if you divide any number by 0, the answer is not defined. So basically, this has no meaning. Okay, 8 divided by 0 or any number divided by 0 is meaningless. Okay, it's not defined. So these are some division facts. Now let's solve some basic problems related to division. So try to answer this in the chat box quickly. Okay, Swastik, good. So essentially we have to divide 54 into 6 parts. Okay, 6 equal parts. Okay, good, Yashika. So we have 54. 1, 2, 3. Okay, and yeah. So 54 divided by 6 is actually 9. Okay, so each boy has $9. Okay, now let's quickly look at the long division. So first few terms. So let's say we have 7 divided by 3. Okay, so we use this symbol to represent division. Now 7, or the number which is being divided, is known as dividend. Okay, the number which divides the dividend is known as divisor. Okay, then we have quotient, and finally, whatever is left is remainder. Okay, so any questions here, guys? I hope you guys are familiar with these terms. So there is this relation that dividend is equal to divisor times quotient plus remainder. Yes, any questions? If no, then please give me a thumbs up quickly. Okay, Swastik, Parth, Yashika, fine. Okay, so fine. Now let's look at division by a one-digit number. Okay, so here you have to divide 36 by 5. So what's the quotient and remainder here? Guys, please answer. So how do we divide? Now we look at the dividend, okay? And now since it's a two-digit number, we will look for a multiple which is closest to the dividend, okay? 36. So if you look at the multiplication table of 5, 5 times 7 is 35, okay, which is closest to 36. So a number which is closest to the dividend, and it's actually less than that, less than or equal to it. Yes, was the correct. Yeah. So 5 times 7 is 35, and 36 minus 35 is 1. Okay, so we can say that quotient is 7 and remainder is 1. You can also write 36 as 5 times 7, okay? Divisor times quotient plus remainder. So you can verify this relation. Okay. Yashika? Okay, fine. Now next, let's divide a three-digit number by a one-digit number. So guys, try this one. So we have to divide 312 by 4. Okay, Yashika. So since it's a three-digit number, okay, so we will first look at the tens digit and hundreds digit. Okay. Now this is 31. So in the multiplication table of 34, we will look for a number which is less than or equal to 31. So we know that 4 times 7 is 28 and 4 times 8 is 32. Now 32 is greater than 31, so we have to use 28. 4 times 7 is 28. Okay, guys, good. So I think 79. Swastik and Parth. What are you doing, guys? So 31 minus 28 is 3. Now we have to bring this 2 down. Okay. So this becomes 32. Wait. Okay, Parth. Yeah, so it has to be 78. So minus. Now again 32, we will look for a number which is less than or equal to 32. Okay. In the multiplication table of 4. Now we already know that 4 times 8 is 32. So So quotient is 78. Okay, and remainder is 0. Fine. So this is done. Now let's try this, guys. Yeah, quickly. Yeah, Shika. Okay, yeah, Yashika, that's correct. Others, quickly. So here again, we'll look at the hundreds digit first, since the hundreds digit itself is greater than the divisor. So we can actually use this first. So 7 times 1 is 7, 8 minus 7 is 1, then we'll bring down 9. Okay, so is that correct? Then 7 times 2 is 14, then 5, and finally 57. 7 times 8 is 56. So quotient is 128 and remainder is 1. Okay, Parth, yeah, Prince. Fine. Now, next we have a 4-digit number. Yes, Parth. Okay, fine. Now try this one quickly. Okay, Yashika. 973. Hmm. Prince, check your answer. Okay, Swastik. So here, if we look at the thousands digit, is actually less than divisor. Okay, it's less than 5. So we have to consider these two together. Okay, so 48. Now, multiple of 5, which is less than or equal to 48, is 45. So 5 times 9 is 45. 48 minus 45 is 3. Then we bring down 6. Okay, then 7. We bring down 7. Wait. And 5 times 3 is 15. Okay, Parth, quotient is 973, remainder is 2. You're actually writing the number in decimals. Okay, that's a different thing altogether. Fine, is this clear? Prince? Okay, let's move to the next question. So here we have a word problem. So try to solve it quickly. But Parth, that's not how we define remainder. Okay. Going by this definition, then you will never have a remainder, right? So yeah. Okay, Yashika, Swastik, others. So here we have 5,832 packets of bread. There are four kinds of bread packets, and there are equal number of packets of each kind. Okay, so basically we need to just divide 5,832 by 4. Yes. Okay, Parth, Prince. So 4 times 1 is 4, then 18. 4 times 4 is 16. Then 4 times 5 is 20. And finally, we have 32. 4 times 8 is 32. Okay, so 1,458 packets of each type. Okay, now try this. Okay, so Yashika, the question is how many marbles would be left? So, what should be the answer? So, basically, we need to divide 4,600. Yeah, Yashika. 4,692 into 9 parts. Okay, 9 equal parts. And after that, few marbles would be left. So, essentially, we need to first divide 4,692 by 9. Okay, Swastik. So, when we do that, quotient is 521, remainder is 3. But the question is how many marbles would be left? So there are 3 marbles. Okay? The answer is 3. Fine. Okay. Now next, let's look at the division by two-digit numbers. So here we have 94 and 13. Yes, Parth, that's correct. Okay. So try this one. So to solve this, we need to know the multiplication table of 13. Okay. We discussed a trick to write the multiplication table of any two-digit number, right? So you can use that, or if you remember it, then you can easily solve this problem. Just quickly answer. Yes. Okay. So others, 13 times 7 is 91. So quotient is 7, remainder is 3. Yes, Swastik, Parth. Yes, okay, fine. Now try this one. Okay, Yashika, 47 and 8. Let's wait for others. Yes, Parth, Swastik. Parth, okay, Parth. So 19 times 4 is 76. Okay, Swastik, fine. Then 19 times 7 is 133. Yeah. So quotient is 47, remainder is 8. Okay, now we have to divide a 4-digit number by a 2-digit number. So we need to divide 3708 by 18. Try this. Okay, Yashika. Others? Yes, Swastik. So 18 times 2 is 36. Then 37 minus 36 is 1. We'll bring down 0. But now the problem is 10 is actually less than 18. So we need to bring down 8 as well. So when we bring down another number, you need to put a 0. Okay. And then 18 times 6 is 108. Okay, fine. Yes, try this. 828 oranges are packed in 36 boxes. How many oranges are packed in each box? Okay, Shika, others? So we need to divide 828 by 36. Okay, Parth, Swastik, correct. Fine. So 36 times 2 is 72. And then 36 times 3 is 108. Okay, good. Yeah, try this one. Okay, Yashika. So 626 people took bus to reach Shimla. 15 people can sit in one bus. How many buses are needed? Okay, the question is how many buses are needed? Yeah. Okay, Yashika. Swastik. The question is how many buses are needed? Swastik. What's the answer to that? 626. So we need to divide 626 by 15. 11 buses. No. Swastik, think. So 15 times 4 is 60. No, Parth. Yashika, yeah, 42. So see, when you divide 626 by 15, we get quotient as 41 and remainder is 11. Okay. So now 41 buses can accommodate 615 people. Okay. In 41 buses. Now still 11 are left, isn't it? So we need another bus. Although this won't be completely filled, but this bus will take the remaining 11 people to Shimla. Okay, so we need one more bus. Is this clear? Parth and Swastik? Guys, Swastik? Okay. Parth? Okay, fine. Yeah. So, okay, now let's quickly solve the worksheet. Okay, so solve it with me. So first one is quite easy. Yeah. Second one is again 8 times 10. Then 4. Okay, yeah. Then next one. Yes. Yashika, check your answer. So 3 times 3 is 9. So 0. 3 times 1 is 3. So yeah. Okay, next one. 7 times. Okay, good. So we bring down 8, then 7 times 1, it's 1. Okay, next one. Okay, Swastik. Parth, are you there? Yes, guys, next one. Okay, Yashika. Correct. 11 and 7. Yes. Okay, this one. Yes, Swastik. Come on, guys. Do it quickly. Okay, Yashika. Parth, you're not responding. Okay, Yashika. 519. So 14 times 5 is 70. 14 times 1 is 14. Then 14 times 9 is 126. Okay, Swastik. Okay, last one. Okay, Yashika. This looks fine. So 27 times 2 is 54. So remainder is 16. Then, okay, Swastik. Good. Now 27 times 6 is 162. So 4 and 5. So 27 times 1. Okay, great. So with this, we have covered the basics of division. Okay. Now I'm going to, discuss one interesting method to solve word problems related to addition, subtraction, multiplication, and division. And with that, we will solve some problems as well. Okay. So fine. Let's start. So this is known as model method. Okay. So what do? We use models, or basically these bars, to represent a number. Okay, this helps us in visualizing the given problem, okay, and solving it easily. Okay, so I'll solve some problems, and with the help of that, we'll try to understand the method. Okay, so let's look at this problem. So here we have an oven. Okay, it costs $860. So what I'm going to do, let's write oven, and I'm going to represent its cost using this bar. Okay, let's say this bar represents cost of an oven. Okay, now next is a washing machine cost $135 less than the oven. Okay, so let's write washing machine here. And now since it costs less than the oven, we have to use a smaller bar to represent the cost of the washing machine. Okay, and the difference is 135. Okay, so can you guys find the cost of the washing machine? Yes, what is the cost of the washing machine? Parth, where were you? Quickly. So 135 less than 860. Okay. Yes, Yashika. Yeah, correct. Okay, so 725. That means this represents 725. Okay. Now, yeah. Now the question is, find the change received by Ben if he paid the cashier $1,000 for the washing machine. Okay. Now, he did not buy an oven. He just bought a washing machine. Okay. So now to the cashier, he paid $1,000. Okay, let's use a different color here. Oh, just a second. Yes, correct. So swastik. So let's say I use this now. So see, this is the amount of money he had, Ben. Okay. Now I'm representing the money, the total money Ben gave to the cashier. Okay. So this represents $1,000. Now, since he bought a washing machine, so that means this much is paid to the cashier. Okay, paid for the washing machine, which is basically 725. So this is remaining, which is 1000 minus 725 equal to 275. Parth, what are you doing? Read the question properly. He paid $725 for the washing machine, so he got $275 back. Yashika? Yeah. So this was a simple problem. Okay. Did you guys understand this? This this model here, how we use the model here? Guys, respond quickly. Okay, give me a thumbs up if you understood this. Parth, okay, fine. Okay, Parth, you need to watch the video again then if your internet is slow. Okay, now let's look at another problem. Okay, so bakery A sold 2088 muffins. Bakery B sold 621 more muffins. What is the total number of muffins sold by the two bakeries? So here again, let's draw the models to represent the number of muffins sold by each bakery. Okay, so let's say Yashika, read the question again. So bakery B sold 621 more muffins. Okay, so that means the bar for this would be longer, and this is 621. So the total would be, yes, guys. Yeah, so bakery B 2088 plus 621, that is 2709. Yeah, Yashika. So now the question is the total number of muffins sold by the two bakeries. So finally, we need to add these two. Just a second. So 2088 plus 2709. Yes, Parth, Swastik, how did you get this number? Bakery B sold more muffins, not less. Okay, and then we have to find the total. Parth, yeah. Swastik, is this clear? Okay, fine. So, yeah, now let's solve another one. Okay, so here we have 125 children. Okay, they took part in a mathematics competition. 54 of them were girls. How many more boys than girls were there? So here again, we can use model. So let's say I represent the total number of students using this bar. Okay. Yeah, Swastik, that's fine. But the question is a bit different. Yeah, 71 boys. That's correct. So this represents the total number of students. Okay. Total number of children. And then 54 are girls and remaining, which is basically 71, of them were boys. Okay. Now the question is how many more boys than girls? So I can again represent the number of boys using models and girls 54. So the difference is 17. Okay. So we are solving these problems using models. Of course, you don't have to use them, but you will see that in some cases, using models become quite useful. So I'm going to discuss those problems in few minutes. Okay, so let's actually now discuss some other type of problems. Okay, now let's quickly go through this diagram first. So let's say we have two quantities and they both are same, then we can use the bar of same size, okay, to represent both of them, okay. And let's call the quantities A and B, okay. If A is double or twice of B, then we can use two such bars, okay, or you call them units, okay. So A is represented by 2 units, B is represented by 1 unit. If A is 3 times B, then A has 3 units, B has 1 unit, and so on. Did you understand these models, guys? So let's say if I use a simple bar to represent 2, to represent 4, I need to use a bar of twice as much size as this to represent 4. Okay. And then let's say if I want to represent 6, then I have to represent a bar of thrice as much size as size of A. Okay. 2, 2. Yes. Is this clear? Swastik, Yashika? Okay. Yeah. So let's try to understand this with the help of a problem. Okay. Let's say, yeah, let's look at this problem. So there are thrice as many apples as banana. Okay. And in total, there are 12 fruits. Now the question is how many apples are there? So what I'm going to do, I'm going to use models here. So let's say first banana. Now let's represent banana by this 1 unit. Okay. One box. Number of bananas. Okay. So number of apples would be represented by 3 such boxes. Yes, guys, is this clear? Okay. Let's say that the size of this is U. Okay. So this is 1U, this is 3U. Okay. And the total is 12. So what do we mean by this? That means the total number of units, which is U plus 3U, should be equal to 12. So I can say that 4 units should be equal to 12, or size of 1 unit is 3. That means now Number of bananas is 3 and number of apples would be 9. Is this clear? Yashika, Swastik? See, bananas are represented by 1 unit and 1 unit is equal to 3. So there are 3 bananas and 9 apples. In total is 12. Okay, now let's try this one. So you guys try it. Try to use models here. Just a second. Yashika, 72. Yes, this looks fine. So see here again, we can use models. So Bobby has 6 times as many stamps as Kelvin. Okay, that means let's say if Kelvin has 1 unit, Bobby has 6 such units. Okay, 1, 2, 3, 4, 5, and 6. Now in total, there are 7 units, and it is given that they have 84 stems altogether. That means total is 84. So 7 units should be equal to 84. So 1 unit would be 84 divided by 7, which is equal to 12. Okay. So Bobby has 6 units or 6 times 12, which is equal to 72. Yes. Is this clear? Swastik? Okay, fine. Good. Now try this one. Mary has 3 times as many stickers as Tracy at first. And Mary has 36 stickers. Tracy double her number of stickers. How many stamps? Oh, sorry. How many stickers? Should be stickers here. Yashika, 54. Okay, think again. So Mary and Tracy. So initially Mary has 3 times as many stickers as Tracy. So let's say if Mary has 1 unit, Tracy has 3. Also, Mary has 36 stickers. That means 3 units is actually equal to 36. 1 unit is 12. So Tracy initially had 12 stickers. Okay, 1 unit is 12. Tracy had 12, Mary had 36, yeah. And then Tracy doubled her number of stickers. Yes, Swastik, correct. Okay. So finally, Tracy had 2 units. Okay, so this is initial. So before and yes, Yashika. Okay, and after, so after Mary still had 3 units or 36, and Tracy now has 2 units. Now 1 unit is 12, so 2 units is equal to 24. So did you guys understand this model method? I hope this is clear. Now there can be a lot of different types of problems. Okay, this can become more complex. Okay. Yes, Yashika. Okay. So with this, let's end the session here. Okay. Okay, guys. Thank you. Okay. Thank you.
Thank you so much, Kapil.
Yes. Thank you.
Guys, this session will be available on YouTube. So if you want to practice or revise your concepts, you can go and check out our channel, and you can revise all the lectures from lecture 1 to this one. And we will continue uploading upcoming lectures as well. Okay.
Okay. Yeah.
Okay. And yeah, next classes are on Thursday, Friday, and Saturday. So we have